All right, so angles of elevation and depression. The biggest thing about these two is that you're always going to have a horizontal line, and the angle of elevation is using that horizontal line and an object in the observer's line of sight. So here is our horizontal line, and the top of this lighthouse is the line of sight. So those two lines will create that angle of elevation. All right, so we're going to use trig to solve these. And sometimes if you see, like if we're trying to find the height of this lighthouse right here, obviously that's not just this side, right? That would be this side and then plus whatever the person's height is. Sometimes we will go off of the person's height and we'll use their height and we'll have to add it to that x that we get. But sometimes it won't give us the person's height. So in that case, we will just use the ground as if they're looking out of their feet. I know it's kind of weird, but it just all depends. So that's kind of what we're going for here. Let's get started. So Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. And they did give us Casey's height. Casey is 6 feet tall. Okay, so here is Casey. Not drawn to scale, obviously, and I'm just going to say that this is the lighthouse. So we have a horizontal line from Casey's eyes. So we know that this distance right here is 6 feet. Okay? Now our angle of elevation is not going from his feet. Now it is going from here, and that will be 58 degrees. Okay, and he sights the top of a 84-foot tall lighthouse. So in other words, the whole lighthouse is 84 feet tall. So this little piece right here is only 78, and that's what we're going to be using. Okay, so the triangle that we're focusing on is this one with the 78 as the opposite side and the 58 as the angle. And then we can just ask how far is he standing from the base of the lighthouse. So we're looking for x right here. So here's our reference angle. This is our hypotenuse and adjacent. So 78 must be the opposite. So they gave us opposite and adjacent, and that's going to be tangent. So the tangent of 58 degrees equals opposite, 78, over adjacent, which is x. We know that we can switch those. And then that should be 48.7 feet. All right, and make sure that you have your calculator in degree mode. If you've been working the past couple of days, your calculator should be already in degree mode. All right, so number 2, this one's a little different. This is the angle of elevation from a kicker's foot on a football field to the top of the goalpost bars. Okay, so here is the kicker's foot, and we're going to the top of the goalpost bars, straight down there, and going across here. So there's our right angle. And that angle is 17 degrees, and he's standing 131 feet from the base of the goalpost. So, you know, that goalpost is actually facing him, so really it would be, you know, the base would be here and it would come out wide that way. I don't know, it's facing him, so we're just going from the base of the goalpost. And how tall is the post? So we're just looking for this right here. So here they did not give us the person's height because we're going from the ground. So we have our reference angle, hypotenuse, adjacent. Now we're using tangent again, but we are looking for opposite. So we have opposite over adjacent, which is 131. We'll just multiply both sides by 131, and that x will give us 40.1 feet. And again, you can do feet as a little tick mark, as I had up there, or you can do it with FT. That is perfectly fine. All right, so moving down to number 4, a dog is standing 5 feet from the base of a tree. Okay, so here's your tree, and here's your dog. Looking up at a cat that has climbed 16 feet up the tree. So we already know that this right here is going to be 16. What is the angle of elevation from the point the dog is standing up to the ground, on the ground up to the cat? So we're just asking for this angle right here. And he's standing 5 feet away from the base of the tree. So now they have given us the two sides. We are looking for the angle. So we're going to have to use inverse trig here. There's our hypotenuse and adjacent. There's the opposite. So we're doing tangent of x degrees, because we don't know that, equals opposite over adjacent. So when we do inverse, the sides and the angles switch, and that will be 72.6 degrees. All right, so that angle right there, 72.6. Now, angle of depression is one that a lot of people get wrong quite a bit, but I need you to focus on this picture right here, okay? So we have a lifeguard looking down at a swimmer, and there's still that horizontal line that I mentioned before. That is going to be the key to everything. Don't forget that horizontal line going from whatever is looking or wherever you're starting that angle. And then it's going down, but we are not using this angle. We are not using this angle right here. We're using the one above it that the horizontal line and the line of sight make. This is a vertical line. Excuse me. That's a vertical line, and that's not the angle of depression. So, and if you notice, if we have two parallel lines here, this is a parallel line with the ground, or in this case, the top of the water. This angle of depression and this angle of elevation are actually the exact same, because this is a transversal and they are alternate interior angles, right? So the angle of depression and the angle of elevation are technically the same thing. And we'll be able to see that in just a second. Oh yeah, and it says it right there, alternate interior angles. They're the same. Okay, so lifeguard sitting on a platform looking down at a swimmer in the water. There's our horizontal line. The lifeguard's line of sight is 8 feet above the ground. Okay, so we know this. And then the angle going down is 18 degrees. So again, here is your angle of depression, not the one here, okay? So then we will have, how far away is the swimmer from the lifeguard? So we're looking for this distance right here. So that's 18 degrees. There's many ways you can do this, but pretty much alternate interior angles, that's how we know that this is 18 degrees. But if you think about it, this will be a right angle, right? And so would the right angle in the triangle. So 18, when you subtract that from 90, because that's a 90-degree angle, that will give you 72. Well, then 72 plus 90 subtracted by 180 will leave you with this other 18. So there's a lot of different ways you can get to it. Alternate interior angles are just a faster way to understand it. So really all we are using is this reference angle, 8, and x. So there's a hypotenuse, adjacent, and opposite. We are using tangent again. You'll find that we use tangent a lot with the real world problems, just because most likely we're judging height and the distance away from something, not necessarily the hypotenuse, the vertical or like diagonal line going across. Diagonal, that's the word I'm looking for. Jeez. It's been a while. 24.6 feet will be how far away the swimmer is from the lifeguard. All right, let's see here. 7 and 8 might be, I'll do 6 and 7. All right, so if a pilot in a helicopter spots a landing pad below, so there's a landing pad, there's a helicopter, spotting it. We have our horizontal line, and that angle of depression is 73 degrees. So we automatically know that this angle is 73 degrees. Now the horizontal distance to the pad is 1,200 feet. So we're not talking about the hypotenuse, we're talking about the horizontal distance, how far away he is. And then we're asking for the altitude of the helicopter. So we have our reference angle, hypotenuse adjacent, and opposite. Using tangent of 73 degrees, and that will be opposite over adjacent. We multiply both sides by that 1,200, and that will give me 3,925 feet. There's your final answer for number 6. All right, for number 7, we got 2 different buildings here, okay? So we got building A, we've got building B. So building A is 480 feet tall. Building B is 654 feet tall. And then the angle of depression from the top of building B to the top of building A, so in other words, there's my line and here's my horizontal line going out, is 42 degrees. then how far apart are the buildings? So we're looking for this distance right here. Okay, so we've got this triangle. We know that this will also be 42. And we know that it's a right angle, but we need to find this other measurement right here. We need to find this, the difference between the buildings. How much taller is building B than building A? So that will be, when you subtract them, that will be 174. I'll do it in blue. So now we have 42, 174, and X. Hypotenuse, adjacent, opposite. We're using tangent again. Tangent of 42 degrees equals 172 over X. We switch them. And that will be 193.2